I don't know of a larger scope in the UK being used regularly for planetary imaging. This is my main telescope, Fossil Light, which is an 18-inch Newtonian, Dobsonian mounted, which I made 30 years ago. Yeah,
30 years ago.
Anniversary. Yeah, 1993. Took 3 years to make and cost about £3,000.
Oh, good, isn't it?
Yeah.
So your pounds per night.
Pounds per night. Yeah, probably quite low actually.
Well, let's go. So what is it? An 18-inch, 20
So it's
inch?
an 18-inch f4.5 Newtonian mirror by John Owen, touched up by Ez Reed.
Oh, nice.
So it's about 15th wave.
So it's good enough.
Really good, yeah, really good primary, and a David Hind secondary, which is also very good. So optically, pretty damn good.
So what have you designed it for?
So originally it was designed for just visual use. So I'm quite keen on, drawing detail in deep sky objects. So I've got many drawings on my website of galaxy groups, planetary nebulae, Veil Nebula, Andromeda Galaxy, hundreds and hundreds of drawings done at the eyepiece here. But then in 2013, so I'd started planetary imaging in 2005 with Mars, with my smaller scope, which is 222mm. So I used that for planetary imaging. I built an equatorial platform, wanted to go up in aperture, and I did this scope out on the equatorial platform. For many years I never had the courage to actually try it, because I thought it would just end in failure, because this scope is so much heavier than the smaller scope, by a factor of probably 6. So, but I tried it out 2013 and it worked really well. So it's probably, I don't know of a larger scope in the UK being used regularly for planetary imaging, on a regular basis. Plenty of 14 inches, particularly C14s.
Yeah. C11s, don't forget.
Yeah. So yeah, I use it, most clear nights when the planets are around and seeing conditions are good for planetary imaging.
It's nice to have them back in the northern sky again.
Yeah. So at the moment I'm concentrating on imaging the night side of Venus. So this is requires large aperture. You operate at wavelengths where the sensor sensitivity is quite low. So you need long exposures. So I'm operating at native f4.5, and with the filter that I've got, which is a Pixeltech 110 nanometer, 38 nanometer bandwidth filter, you can actually, Venus's atmosphere is transparent, so on the night side you see the thermal emission from the surface is at 460 degrees, gives off heat, that makes it through the atmosphere, and telescope picks it up, and you see variations in that thermal radiation which relate to surface features on the planet. So you can see the surface, you can see higher and lower areas of the night side. There's probably about 10 people in the world that are doing it at the moment. So there's a group's IO group set up specifically for this, and I'm contributing to that.
Oh, fantastic.
Yeah.
So what's your favourite planet? What if you could choose one? What would you go?
I
they
guess
all
Venus good? Actually. Venus, the beauty of Venus is you see very much depending on exactly what filters you're using. So visual, fairly bland visual, but aesthetically can be very pleasing. Infrared, you start to see some detail. 110 nanometers, then you see the surface. UV, then you see cloud details, quite significant cloud details. So it gives in so many areas, Venus. Yeah, I really like Venus.
I thought you were going to go for Jupiter. Jupiter's my favourite because it's always changing.
Yeah.
Yeah, 1 hour to the next, it's completely different.
Yeah, they're all different. Each planet you image in different ways and has different difficulties in imaging, and gives back in different ways. keeps it really interesting. Mercury's the other planet that I image in the daytime.
Of course, yes.
Not with this scope, but with my smaller scope. I take infrared images of Mercury, and you can see albedo features on there.
Fantastic.
And that's got its own challenges, imaging in the daytime. I really take
Yes.
my hat off to solar images, because the seeing is just so much worse than at night time.
Yeah.
It really is shockingly bad.
Cool. Let's have a look at the telescope then.
Okay.
So how did you... Let's have a look at this.
So when I built this in 1993, essentially the internet didn't really exist. Hard to believe, and there weren't books on building Dobsonians. There was a magazine, an American magazine called Telescope Making, black and white, almost a newspaper style magazine, and that had pictures in it of scopes, star parties, meets in America, and they had articles about people describing the scopes that they'd built. And this Seraria truss, which is eight trusses like this, making up triangles that keeps it really stiff between top and bottom, is absolutely essential. So that's the heart of it, is this Seraria truss. Corners, if you want to swing around, but you might be able to see. No, you probably can't, but there are 4 fans in the corners there. They draw air down the tube, and then I've got an air dam around, a soft air dam around the mirror
That just
that
recirculates.
prevents the air that I'm blowing in at the back of the mirror going up the tube. So I'm drawing air down, blowing on the back of the mirror, and then it goes out. So it's quite a complicated arrangement, but it works really well.
And that keeps it from a hot day into a cold night.
Yeah, well, I keep it in the garage, so it never gets too warm. Don't keep it in the house. Keep it in the garage, but it's always a few degrees warmer than ambient. So that's the bottom end. You've got collimation knobs here. That's fixed, so I just collimate with 2 knobs there. Otherwise, if you have 3 knobs, it progressively moves up the tube or down the tube and changes the focal position, which I don't want. So having one fixed stops you doing that. So effectively the 3rd knob adjustment is done by altering these 2 together.
And then with the ventilation in the middle.
Yeah, ventilation in the middle and the ventilation around here. There's a lot of aluminium on there, lightweight, very strong, rather than wood.
So should we, for the Americans, then we have to say aluminum.
Yeah, aluminum, exactly. The wood, there is wood in this, particularly in the bottom base box there, which is solid wood. And the key thing with these Dobs is to have a very thick bottom board there that doesn't flex at all. So actually that bottom board is about this thick.
Oh wow.
So it's plywood, 1/2-inch ply, then insulation. So I've got a very stiff polyethylene insulation in between, and then another board on top. So it makes it's a composite board that's very, very stiff because it's so thick.
So there's no telescope like this in the world, is there? That's the beauty of having a homemade specialised instrument.
Yes, and you can make it exactly how you want it, you know, and
so if you optimised it for planetary or for deep sky, have you gone down the small secondary and
yeah,
you
it's
obviously got the
as
active
small a secondary
cooling?
as I can get. So there's an 86mm secondary, which is about 20%. Yeah, I think it's just around 20%. So that's probably about as small as you can get. Got low profile focuser. So at the top end, I've added this for planetary imaging, which is an electric focuser. So I've got a DC power electric focuser, and to just switch the focuser in, I just put that clamp on. Otherwise, it's just visual like that. So it's a sort of clutch system. So I put that on there, and then plug in a DC pulse generator that produces positive or negative pulses depending on which direction I want to use that. But that's really the only thing I've added for planetary imaging. You know, you obviously use it on an equatorial platform, but you know, that's in there. It's got dew heaters, so dew heaters which heat, so the spent a huge amount of time making us a reasonably large finder. So this is
what is that? I was going to ask you what your finder
is.
is.
60mm finder, home built and ultra lightweight, with cardboard and PCB board fiberglass wrap around it, so that's made a really stiff tube that's as light as it can possibly be. Because as I said before, it's really important this top end is as light as possible to keep that centre of gravity low. It's like an 8-to-1, so every you know 10 grams added here, you need 80 grams at that end to balance it out. So I've made this as light as possible. This is a composite board. This is aircraft composite board, so it's paper with a fiberglass skin, top and bottom. This is balsa wood, so this is a ring of balsa wood with mahogany blocks where these rods come up. This is my sister's old shower rail, which is oval cross section.
Did she know you'd taken her shower rail?
Yeah, she threw it out, so I'll have that. I know exactly where I can use that. So there are mahogany reinforcement points, and then the whole thing's been coated with, again, PCB fiberglass, 0.4 or 0.25mm thick, as a skin on the outside.
So you've really optimised that bit for being lightweight to reduce the overall weight.
Yeah, if you had a normal fibre, say you had a normal plywood ring here, it would be so much heavier in weight. And it's, you know, this composite method's been used all the way through the top and the board.
What composite is it?
So that's balsa wood.
Oh, balsa.
As I say, it's a ring of balsa wood
with a skin.
With a skin of fiberglass, and then that's a composite aircraft board, which is a paper matrix with fiberglass on it, and same as that. That's the same material as that. But again, you know, lightweight, very strong. Yeah.
And what's the silver foil for? Is that when you get cold at night, you wrap it around yourself?
So silver foil, so that is an emergency blanket, the sort of thing that runners use to keep warm. Its primary purpose is to reduce radiative cooling of the telescope at night. So the night sky is minus 30 degrees. It might be 10 degrees outside. You've got a very cold night sky. Top of the scope is pointing at a cold night sky. It'll cool down below ambient, and without this it could be 2 to 3 degrees below ambient, and that will set up what's called inverse tube currents. So you'll just get cold air from the top of the telescope tube descending the tube, and it'll just go on all night long. Not many people know about these inverse tube currents.
And even the aluminium poles have got...
Yeah, aluminium poles have got insulation on them, and that makes a big difference because it's got a very low emissivity, aluminium. It stops it cooling down so much. So this will only be about half a degree below ambient.
And that's why my Celestron C11 has a space blanket.
Yeah.
Following your advice.
Yeah, and it does make a big difference to these inverse tube currents. Once the mirrors cool down, you think, you know, tube currents will die away, but they don't. They will just keep going because of that. Yeah, really pleased. So if anyone wants to see my sketches or digital video images, skyinspector.co.uk, visit that. I've also got a Twitter handle @skyinspector, where all my latest images and drawings and things are put out.
Twitter? What's that?
I'm sorry, X, I should say. So yeah, visit that. I've also been running, while I'm at Kelling, I've been running an all sky camera, so I don't know if you want to have a quick look at that.
I was also going to ask you about your high-tech ladder.
Oh yes, so this is my essential observing ladder. which is a modified ladder. Got a pole in it, absolutely essential for steadying yourself, particularly on the top step here. Often lean against the pole there, reduces fatigue. Soft fronts there, because when you're standing on the lower rungs you don't get bruised shins, and enlarged pads at the bottom there, stop it sinking into the soft earth. So that's again a modified thing. The pole clips onto the side there. You know, I love having these technical challenges and solving them, and just, you know, and moving on from that. I hate having things that don't work properly. I hate, you know, a lot of people get caught up in the practicalities of imaging and observing, and rather than doing what they have set out to do, they just spend that time during the session trying to overcome things that you could solve in the daytime to maximise the time that you're imaging or observing. So every time something goes wrong, I then think, how will I solve that so it never happens again? Because I get annoyed by it.
So you design it out. That's the key, isn't it? Design
so one
mantra.
thing that happened. So last year I was imaging. I wanted to image Uranus, and it was a particularly dewy night, and the eyepiece dewed up. Now Uranus is actually quite difficult to find. You know, it's supposed to be.
Yeah, you can't see it, can you? You need binoculars or.
Yeah, it's really quite hard to find Uranus. So you can star hop, but you obviously need a good finder for that. So this is dewed up. I put my heaters on. That drove the moisture. So I've got a heater band around here and a heater band around here. So that cleared. The eyepiece cleared, but it drove the moisture onto the roof prism that's in there, and the roof prism dewed up, and I couldn't use the finder. So the session was a wipeout. I thought I'm never going to have that happen again. So what I did is I got a pin, fitted that on the bottom there, opened up the back of the finder, and I've got bags of desiccant in the back there, which I change each season with a rubber seal around it, so that it never happens again.
You only do it wrong once, do you?
Yeah, exactly. That's the idea. It only goes wrong once, and then you take action and you make sure it never happens again.
Design it out. I like that.
Yeah.
Cool. Let's go and have a look at your full sky camera then. That's where we were going before the ladder distracted us.
So again, this was a little project. I did a review of an all-sky camera for Sky at Night magazine, which was an analog all-sky camera. So the main part of this is this environmental enclosure, because you don't want rain to get in and you don't want it to dew up. So with this all-sky camera, it's a bit of I don't know what this material is, it's probably ABS or something like that, tubing, cut down, then a ring, a sealing ring in between. There are bolts that pull the top together to the bottom there. I've got a security camera dome that I bought off the internet, that's glued in, and then inside I've got a fairly common planetary imaging camera, an ASI 174 mono, which has got a big chip on it, and then the really key thing is this fusion on lens. So I got this fusion on lens off eBay, which is an absolutely excellent lens.
And that gives you 180 all sky.
That gives 180 degrees, yeah, horizon to horizon, very high quality. Works absolutely fantastically with that ASI camera.
And it's quite interesting just reviewing it afterwards.
Yeah.
Was it 15-second exposure?
Yeah, so I've been using 15-second exposures at a gain of 200, and then stitch them together in PIP and run it back as a time lapse at 300 speed, so 300 times faster, and then you see the whole night passing in probably a couple of minutes.
And when you have visitors and they say, "Shall I put my coat on this?" That's a distinct no-no.
Yeah. Please don't do that. So that's got dew heater in it and a fan. So there's a little fan in there that blows the air around, and a heat sink with a heater on it. So it's got to be supplied with DC. So there's a DC in, and then my USB 3 cable out that goes into the car to the laptop.
Oh, you just record onto the laptop?
Record onto the laptop during the night, yeah. And then there's little LEDs. So there's one LED that says, "Have I got power?" And then another LED that says, "Dew heater on." There's a bimetallic strip in there that switches it on and off. So when it gets too hot, it'll just automatically switch off. But that's completely waterproof. So no rain's going to get in there. And it's on a sturdy tripod.
Because we had the rarity of a dew-free night.
Yeah. It was the Friday night, which was essentially clear all night long. Although it had rained very heavily in the day, was dew-free because it was quite breezy.
And so transparent with all that rain.
Yeah, really good. So
what was your highlight? What was your observing highlight for that night?
That night, probably the little dumbbell. Had a really nice view of the little dumbbell. Good views of the Veil, Crescent Nebula, with low power and an O3 Astronomics 2-inch O3 filter. Absolutely, yeah, tremendous views of the Veil. Yeah, but I think the little dumbbell came out really well.
Nice. So it's wonderful, isn't it? You've got a visual deep sky, planetary imaging, tracking. Yeah,
it's a good all-purpose scope, and 30 years been using that, and served me really well.
No plans to upgrade, or?
No plans to upgrade. I think 18 inches is probably the largest, for a Newtonian, the largest easily manageable size.
In terms of weight and portability.
Going to 20 inch, you know, you think, oh, it's only 2 more inches aperture, and you would get slightly better views, but it's probably about 30 to 40% heavier and longer, and then you need a longer ladder, and it just tips over the edge then, I think, once you get beyond 18 inches. 18 inches is about as big as you can easily manage.
Well, there's no doubt it pulls the results in, does it?
Yeah.
Well, thanks, Martin. So skyinspector.co.uk.
That's it,
Yeah, lovely.
Good.
And on X, Twitter.
Yeah, and on X, Twitter, yeah. So all my latest stuff is on X. So check them out.
Perfect. So my thanks to Martin for his time at the Kelling Star Party, where we had such a wonderful time observing the night sky on that beautifully clear night. Martin's got such a wonderful telescope and such great knowledge of sketching, of planetary imaging, of observing the deep sky. It's really wonderful to catch up and understand his observing setup. If you're also passing the National Maritime Museum in Greenwich, at the Greenwich Observatory, he's even got images on display at the Astrophotography of the Year competition. And do check out his website, skyinspector.co.uk. See how he achieves these wonderful results. Maps of Mars, observing the night side of Venus, deep sky observing of galaxy clusters. Absolutely fascinating to read. So my thanks to Martin. One of the things I have been conscious of is I didn't produce any content for several months, so I've actually set up a Patreon account. And if you'd like to support Refreshing Views and help us produce more videos to encourage us to observe the night skies, these tutorials and these observing sessions, then please do check that out. I'm conscious that I didn't produce anything, so this will give an incentive to help produce videos for you, the community. Someone was saying to me the other day, these videos, they are free to watch, but they certainly aren't cheap to produce. So this will really help and encourage and help keep those lights on at the Refreshing Views Observatory, or rather keep the lights off at the Refreshing Views Observatory. So if you enjoyed that, don't hesitate to subscribe, and I'll bring you more videos as we explore the night sky.